recording the video. Looks like it's going. And then next to it is the people, so you can click on that and see who's here. I'm going to open up the chat. So Kaylin, you can't hear anything. You'll want to check, go into your audio and check to see if you can hear things through there. If you click on the three dots, what they sometimes call a snowman, you should be able to see speaker, microphone, and camera. If you click on that, it should take you find that is to click on the snowman or the three dots. Aha, speaker, microphone. Okay. So.
Do you want us to also cut the video feed from our camera? Does that help?
Nope. You can leave the video on. That way I can see from your faces if you are understanding or not understanding. Okay. But again, you need to make sure you keep it on mute, because if you don't, Christian, you got to keep it off. You've turned it back on again. All right. So you are still talking. So you've got to keep it off or we're going to get lots of feedback. It'll drive us all crazy. Okay. In the chat, you can click on the chat and you can either click to talk to somebody specific, or you can click to write a chat to everyone, and I'll ask questions and you can give me feedback through the chat. Okay. Now, how do you get into the system? If you are in D2L, and I'm going to pull up, oh, nope, not OneNote. Pull up, yep, D2L, there we go. Okay. So I'm going to share my screen with you so you can see what I'm seeing. All right. Google Chrome. Yeah, I want to show that. Okay. So now you should all be able to see, looks like Joanna Debrecht's online WebEx room. All right. Some of the links weren't working, so I ended up going in here and pasting it in 3 times. So hopefully these always work. So the place to find that is to go into content, and I added it right here as the first item under the weekly online modules. So from now on, you'll mostly be coming to the weekly online modules, and you can click on any of those 3 links. It should take you in here, right? If you have trouble for some reason, if the internet goes really bad at some point and you can't see it, you can dial one of these 2 phone numbers here and enter this meeting number, and you can at least listen on the phone. And then later when I upload the video, you'll be able to see everything that was done, okay? So there's still a way to listen even if for some reason your internet's not working. I did post some announcements, and I have also posted what our plan is, at least for the first week. So I'll probably be posting them week by week because things are going to change. Things have been changing almost by the hour at work, much less by the day. It's been insane. So what's happening at the moment is, for as far as we're aware, classes will not resume face-to-face for the rest of the semester. They're going to be online. The tutoring center at the moment is closed. We are working on ways of getting tutoring access to you online. So we're working on that. In the meantime, I will make sure to have office hours immediately for your class, immediately after class, so that you have an opportunity to ask me questions every day, okay? And if you send me questions overnight, I will try to have those preloaded in so that I don't have to take time during class to cut and paste the problems in. So anything you can do to send me screenshots of problems you're having ahead of time will be really helpful, and it will really speed up the class process. The internet is already slowing down. During my Cal 2 class this morning, the lag at times was as much as 7 seconds between when I'm writing and when it's showing up. I'll get to that, Shane, so don't let me forget about it. So Shane was asking about homework, how we're going to do homework. So this is how you get into the class. This is also the same place that we'll meet for office hours, and it's also the same place where you'll be taking your exams. So for right now, I'm going to use WebEx for everything. If it gets too unwieldy later on, I may have to use Zoom as well. But that does mean that there's going to be a little bit of overlap between you guys and the Cal 2 class. The Calculus 2 meets at 9. So my plan is for them to meet at 9 and they'll stay on until about 10:15. And then I'll probably do an office hour for them right after class. And then I will start you guys at noon, and then I'll do some office hours for you guys. And then I'll open it up to whoever has questions if I'm available. I will also probably, because I'm anticipating so much lag on the internet, and I really think it's going to be an issue, I have my own video recording system at home that does not depend on the internet. So I am going to pre-record lectures, and we're going to flip the classroom. So what we're going to do moving forward is I'm going to pre-record. You'll watch the video of all the content. Then you'll try working the problems. You will send me problems you're having with issues, something that doesn't make sense to you. We'll come back the next day and we'll talk about those things, okay? In order to try to lecture online, I'm afraid the lag time is going to be too severe. So we're going to flip it, and you're going to be watching the video ahead of class, and then we'll be working mostly problems in class. So hopefully that makes sense to you. You will be taking your exams remotely. That means that I'll put them in the assignments folder, which on D2L is right here. So the assignments folder is here, and your exams will be done in there. Exams will be proctored by me. So you will come into the classroom just like you are right now. And I will open it up for you, and you will basically one at a time, I'll go through, and you'll do like a pick up your computer and walk around the room and show me that Josh is not hiding in the corner, basically, okay? So you don't have a tutor hiding. And then you just take the test. I watch you take the test, and then you'll upload it that way. I do have a document to explain how to do that. So if we go to our homepage, I don't believe I've uploaded it yet because we don't have an exam coming up yet. But I do have a document on exactly how to do that. If you have a touch screen and a stylus, it's much easier. If you don't, if you have a printer at home, it should be okay. You can print out the exam. The students who don't have a printer and don't have a touch screen, you're at the biggest disadvantage. You'll just have to take blank paper and handwrite the problems and then take photos and upload it, okay? And I have a document on how to do that, and I'm going to prepare a video on how to use at least one of the apps to convert all your photos into a PDF file using a cell phone. The problem is I'm limited as to how much space I can use on D2L, and videos are enormously large, and we have a lot of videos that are going to have to go in here. On average, one photo is equivalent to 20 Word documents. So anything that you can do to shrink the size of your files will really help. So when we do tests, I'm going to ask that you convert them to a Word file or to a PDF file. But again, I'll show you how to do that. I have extended the homework to Thursday, 4-1, 4-2, and 4-3. And I delayed the quiz until Thursday because you hadn't met with me yet and things have been so crazy. I just thought we needed a little more time. So if you click on assignments, you'll see that's where I've put the quiz. The quiz is down here at the bottom, quiz 7 online. It has a deadline of tomorrow at midnight, but it doesn't open, I don't believe, until 2:05, I think, possibly. It's down here in an announcement somewhere. I can't remember. I think I said 2:05. I can check it and see. Let's look. I wanted to make sure you had a chance after class tomorrow to ask me questions before you started the quiz. So, restrictions. Yep, it starts tomorrow at 2:05. So 1 hour after class ends, you can start taking the quiz, all right? And it's due by midnight. Okay, so other items that we need to discuss. This is how we'll do quizzes. We'll do exams through the assignments folder as well. And I am developing some things on how to upload all of that. I'll have all that out there in a folder, and I will put it under the online weekly module, right? So when I get it all prepared, I'll create another folder under weekly online modules that says how to take a test, okay? The other thing that we need to talk about, now that we know sort of how we'll do quizzes, we know how we'll do exams, is homework. Yes, you could scan in all your homework, but it would take you too long. It would take up a lot of memory on D2L that I'm afraid I'm going to run out of, so I don't want to do that. So what we're going to do instead, and what I think will be more helpful, especially since the tutoring center is not available, is to use the discussion board instead. So this is what I typically do if I teach an online class. And what I have students do instead of posting all of their homework problems is they choose a problem. But I don't want you guys to choose the same problem. So you should have plenty to choose from. In each weekly discussion board, you need to post minimum of 1 problem, but no more than 2. 2 is plenty. And I want you to choose one from section 4.1, 4.2, or 4.3 for the first one. That does not mean 1 from 4.1, 1 from 4.2, 1 from 4.3. It means 1 from any of the 3 sections. What you're going to do is you're going to post in your actual work. It's okay to post a PNG or a JPEG file here. You can also upload a Word document or a PDF file. If you don't have the capability to do that, there's also an equation editor. What you're going to do is there's a subject line on the discussion board, and you're going to enter the chapter number, the section number, and the problem number into the discussion line, the subject line. Let me show you a little bit how it's going to work. While we're doing this, I am actually going through and adding captions to my Cal 2 class. So if you see me glancing over to the side, that's what I'm doing. So let's click on week 9 discussion board. This is exactly what you'll see. It's going to open up, and let's say I decide I want to work on 4.2.5. So I'm going to start a new thread, and in this subject line, I'm going to type 4.2.5. There's a couple reasons for this. One, the purpose of the discussion board is for you guys to help each other. You can't come on campus safely. The tutors are no longer there. They were going to be there, but as of today, it's all shut down. The testing center is closed, the tutoring center is closed, and in very short order, nobody's going to be going on campus. So until we can figure out how to get the tutoring online, your best option is to use the discussion board. You will be able to search in the original discussion forum for any problem you're looking for. So let's say you're doing your homework and you're stuck on 4.2.5. You can search for 4.2.5 and it will bring up all the threads that refer to that. And that way you can get help on a problem that you're stuck on that maybe somebody else got, okay? So in here, let's say that you're doing some work and you can type whatever you want in here. There are a couple buttons in here I want to show you. First off, you've got the 3 dots over here, what's sometimes called a snowman, although this one's kind of a sideways snowman. If you click on that, it gives you more options. This symbol right here looks like a sigma, the Greek letter sigma, which means sum. If you click on that, it's going to open up an equation editor. So I said if you don't have access easily to being able to write it as a Word doc or a PDF, you can use this. So you just click in the box and you can start typing. These are templates like anything else you've probably seen on My Math Lab. You can put in x squared, and then if you want to type something else, remember you've got to move out of the exponent, so you've got to move sideways. You can add parentheses. Over here, we can even do limits if we want. You need to click here and say as x is going to infinity. You can type in pretty much whatever you want. When you're done typing, you click on insert, and it will insert that right here. Now this becomes an object. You can make it larger. If you think it's hard to read, you can make it smaller. You can copy and paste it, but you can't edit it unless you highlight it and then click on the sigma again. It will bring you back into the same box, and you can correct something if you did something wrong. So this is one way that you can post problems if you want to. I will be honest, I find doing it this way really long and tedious, all right, because it takes a lot of clicking to get that stuff in there. So I want to show you 2 other ways. If you are looking on your computer keyboard, there should be a bar somewhere where it says type here to search, or you can search somewhere in your computer for something called a snippet. How many of you have ever used a snipping tool? Okay, good. If you've used the snipping tool, then you know what I'm talking about. The snipping tool I use is pretty much the old basic one, which looks like this. So, and it says at the top, snipping tool. Now, oh, you can't see it. Okay, share. All right, now you can see my snipping tool. All right, so if you're looking, you can see that I've got something in here. Let me show you how to use the snipping tool. All right, so let's say that I am looking at this one note and I want to copy off this right here. I click on the snipping tool and I click on new, and it will gray out the screen. Now I can still move the bar at the top, and I can move it away from what I want to snip. Then I use the crossbars to highlight and drag and drop while holding down the left mouse key till I get what I want. This has already copied it off onto the clipboard. It's there. You don't have to tell it to copy it. It's already copied. If something messes up, you can also click copy and it will copy it. You do have the ability, if you have a snippet, to use a pen, and you can actually write directly on here. So in theory, you could snip and you could write on here to do your work if you want to. What I like to do is just paste it directly. You can save it if you want. If you want to save it, then you can save it. It usually saves as a PNG file, which is what's best for putting it into onto the web. So once I have that there, I'm going to come back over here and I can click to the end and hit return. If I do Control V or Control Paste, you can see it automatically puts it in. And then you can shrink the size of it, you can grow the size of it. Usually Snippet puts it in larger than what you want, so you usually want to make it smaller. Remember that you can also grab the 3 bars in the lower right-hand corner and make it longer so you can see more at one time. All right. The other thing that you can do with Snippet, like I said, is you can save it. So I'm going to save this one, and I'm just going to save it as the name of capture. You can see I've done this many, many times. I have lots of captures in there. Okay, now if I come back over to here and I do return, up here at the top where there's a link and there's a picture, the picture will allow me to insert an image. So if I click on the camera, I can go to my computer and I can drag and drop something in. I could add it as an attachment, or I can click on upload and do a search for it, which I believe I put it in pictures and saved pictures. And I think I just called it capture. And then I tell it to open it. And then I tell it to add it. And I tell it it's decorative text, so I don't have to write about it. And you'll see that it pasted it directly below. So that's a couple different ways of getting stuff in there. You can also insert a quick link if you want to. A quick link will take you to like a URL or something like that. I can't imagine that you'd want to do that, but you could link it to like your Google Docs account or something, but I don't recommend doing that, but you could. Now, how would you get a Word doc or a PDF in here? To get a Word doc or a PDF, you can add an attachment, which is down here. Same thing, you can upload it or whatever. You do have the ability to video record or audio record. I don't think you need to video record, but if you're lost on something, you might record a message that says, hey, I understood how to set it up, but I got lost in line 5, okay? Okay, so let's talk about how you're going to get graded on these. The purpose of the discussion board is not to be perfect. The purpose of the discussion board is to figure out how to solve the problems. So it is okay to post something that says, I solved this problem, but I'm not getting what WebWork is getting. Can anybody see where I made a mistake? If you do that, you'll still get full credit for it. If someone comes along and sees your post and they respond to your post and they find the error in your work, and they explain to you what was wrong and they go through and correct it in a response to your post, then they'll also get credit for that work. So you don't just get credit from doing the work, you also get credit from correcting it later, okay? You can get credit either way, by posting your original work or by helping somebody else. When you're done, you want to make sure to hit post, and that will put it in there. And it should tell you the thread is created successfully. And then once you get that in there, it will show up for everybody and they can click on it. That makes this a hot link and they can respond to you. Now, if you've ever taken any kind of class before, you would hit reply to thread here. And when you reply to the thread, you'll notice that if you've pasted in a picture, the picture will actually show up in the thread, in the reply. And you can reply right here with what you thought they did wrong, okay? And then the reply you would also want to post. Okay, so you might post something like, I got the same answer, but I solved it a different way. Okay, and then you might post, here's how I did it, right? And then you would post your work, right? So all of those are acceptable things to post. And then everyone will be able to scroll down and they can see what's being said in that particular post. Now, if you go back to the original topic, there's a place at the top where you can search for things. So if you want to filter, you can filter through the threads and you can search for things, which will let you find stuff. Okay, at the moment, there's only one thing in there, so you can't really search. Okay, so this is how the homework is going to be graded. For right now, we'll post 1 or 2. It would probably be better if you posted 2. Try to post something that no one else has posted. If we ever get to a point where every problem has been posted, then it's fine to repost with different numbers if your problem has different numbers. But for now, try to post something other than what everybody else has done, okay? I think this will work better given that you don't have access to the tutoring center and you're going to need help on the homework, right? So this is a way for you guys to help each other. It's also okay in the discussion board to write something, to post something that says, I'm so lost on this problem, I don't know where to start, okay? You won't get credit for that, but if somebody replies to you and says, oh, hey, here's how you do that, they'll get credit for it, and you figure out how to solve the problem, okay? So the discussion board is meant to help you through this time. If the images take up too much space, I'll deal with that when it happens. I'm hoping that does not occur. I don't remember exactly how much space I get, but if worse comes to worse, I will grade them and then start deleting posts to create more space. I mean, I won't have much choice, I'll have to. But hopefully, probably what will happen is, what's been happening at any rate is the companies are opening up their systems and not throttling how much we're allowed to store. Okay, so I suspect that they will simply allow us to have more space if that becomes an issue. So that's how we're going to do homework. So I expect to see you in the discussion board a lot. All right. Yeah, we could all sit 6 feet apart in my yard and we could talk. Yeah, I don't know about you guys, but I'm going hiking more, at least just to get out of the house. So I'm not stuck in the house, but I try to stay 6 feet away from everybody. Let me go over and see what kind of questions you guys had in the chat. I thought I saw some questions. No, we've covered that. Can you still go to campus to print documents? It was open, but I think it's going to be closed. I am not totally sure about that. My guess is it's going to be closed from now on. It will be open for critical personnel. I'm sure some of the IT people will be there. They'll have to be. Test grades. Yeah, because of everything that's been happening, I am so far behind on grading, but it's on my list of things to do today. And I am going to try to scan them in. I will write directly on the test, then I'll scan them in and I will email them to you. And then I will upload them. So what I will do is I will create under assignments. If you go into assignments, in fact, I can just go ahead and do it right now. I'm going to create a new assignment, which is called Exam 2. And you're going to find that I'm going to upload your exam in here, and that way you'll be able to see it. So I need to link it to, I'm trying to remember, how many problems were on that test? Oh, well, I can't remember. I'll just make it out of 100. And it will be exam 2. All right. That looks good. And I don't want to hide it from you. And I'm not going to put a date on it because I want you to be able to access it at any time. So sometime tomorrow, go in there under assignments, click on that, and you should be able to open up a PDF file, which will be your graded exam, all right? And the grade will be in there. Okay. Any other questions that I haven't covered yet? Yeah, I would say 1 or 2 sections. If you don't do all the web work problems, will it hurt your grades? Yeah, because you won't know how to do the problems. Math class is kind of like you get out of it what you put into it. It's like saying, well, if I go to the gym and I don't lift all the weights, will my muscles grow? No. So yeah, you need to do most of them. Is it going to hurt your average if you still do well in the exams? Then no. So no, I'm not going to grade the web work at the moment. If I see that you're not using the discussion board very much, then I'll have to change the way I'm doing it and require you to post more to the discussion board or to turn in homework. So if you don't use the discussion board enough, then I will have to do something different. Okay? All right. Let me think what else we need to cover. Okay. We should probably talk about where things are. So hang on just a second. Today is the 18th, right? Okay. All right. So today, let's talk about content. Okay. So my current plan was, and hopefully you've already done this, on the week of March 9th, you were supposed to watch videos on Monday and Tuesday when I was in the interviews. And I believe you can still see my D2L page. So if you're looking at that, on Monday, you were supposed to watch some things. I did create a video over last Thursday's material because we did spend some time in class talking instead about what was going to happen. So I felt like I needed to go over that a little bit more in depth. So I created a video at home, and it's right here that you can watch over that. And I created a video over the mean value theorem for Monday and derivatives, part 1. And then on Tuesday, I created another one, which was over concavity, which you were supposed to watch yesterday. I didn't get any emailed list of homework problems, so you're going to have to make sure that in the future you try to send them to me ahead of time because it can take a really long time for me to cut and paste them in while you're there. And then today, we're basically covering sort of how the rest of the semester is going to go. And if we have time, we'll work problems and that sort of thing. I have also created the next one, which is how to do graphs. And then here's your link to quiz 7 online. And it says it will open at 2:05 on Thursday, which is tomorrow. Okay. So let me go through the material I've added down here at the bottom. Now on, so you don't have to be hunting for stuff, I'm going to load everything into this folder. So it will be in here by the week, and that way you'll know exactly where to go to find things. So here you're going to have, I added in an additional video of solving related rates problems because we haven't had class. And I thought it would be better to have those sort of off by themselves instead of mixed in with other topics. So I put the related rates photos or related rates video here. The extrema came next, so that was 4.3. This is the lecture notes that accompany this video. So I took a picture of those so that you would have both if you wanted them. These are the lecture notes that I used for the video on the mean value theorem, which is here. And these are the lecture notes where I cover the first and second derivative test and concavity, and that is here and here. So there's one video for the first derivative test, one video for concavity and the second derivative test. And then there are 2 more files, which is graphing functions and then graphing functions in calculus. So this is the video and these are the notes that go along with it. So this is how I'll be loading stuff in here. And I think for right now, I'm going to just wait and we're not going to touch optimization until after spring break because I feel like just getting a handle on how we're going to run class is enough. So it will take a little bit more effort on your part as far as letting me know ahead of time what problems you're having trouble with. You will have to watch the videos outside of class time so that we can spend class time going over homework problems. The positive side is that you will have videos for everything that you can watch as many times as you want. You can stop them, you can pause them, you can go back. And I think that will be helpful for review purposes, right? So my plan is you'll still get 100% of the content that you need to go on and be successful in Cal 2. So I don't think that should be too much of a problem. I'm not convinced yet that doing Python remotely is a good idea. So I may have to change the syllabus and drop that out a little bit. I'm still thinking about that. We'll have to see how it goes. But for right now, I don't want you to do the next Python project, even though it's due right now. All right. But for right now, I think we should just let that go for a second. And focus on getting this system working and make sure that everybody's comfortable with how class is going to run. Okay, so now that we've covered the logistics of everything, we need to actually do some class. So what I want to do now is open it up to any questions you have off the homework. So what questions do you have off of the homework that you've been struggling with? And you can put them in the chat. That's the easiest way for me to see them. And that way I can sort of see them and pick them out one at a time. So if you will start looking for problems that you want to see and write them down in the format of chapter, section, problem number. So like 4.2.5 or something like that. So I'll give you a minute or two to find those out. While you're doing that, I'll open up WebWork. I can get your homeworks out. All right, 4120, 4115. Okay. All right. So for 117. And your quiz tomorrow is over only 4.1 related rates. And then I think I gave you one easy problem off the linear approximation function, but mostly 4.1. Okay. So let's look at 4.1. All right, so let's start with 4120, since that's the first one in the list. Okay. All right, so all right, so this is sheet class. All right, so first one is 5 point, nope, thinking about 4.1.20. All right, so we're looking at this problem right here. I will tell you, I'm pretty sure that I remember this problem, and the problem in WebWork was coded incorrectly. So if you're not getting the answer in WebWork, that's why you're not getting the answer in WebWork, because they coded it incorrectly. It was supposed to be fixed, but I'm wondering if it did not get fixed since you're asking about it. Okay, so let's go through our steps, which is first we just read it. A swimming pool is 20 feet wide, 40 feet long, 3 feet deep at the shallow end, and 9 feet deep at its deepest point. If the pool is being filled at the rate of 0.8 cubic feet per minute, how fast is the water level rising when the depth at the deepest point is 5 feet. Okay, all I got out of this is it's a swimming pool and they're putting water in it. That's it. That's all I got. Okay, that is enough. I know it's not a plane, train, or automobile, so I don't need distance equals rate times time. It's not a circle, it's not a sphere, it's not a triangle. So now I'm going to go back to the beginning. I start drawing my picture. It says a swimming pool. So let me use my picture. Is, okay, 20 feet wide, 40 feet long. Well, they didn't say, but what are we going to have to assume about the shape of the swimming pool in order to solve this problem? Just type it into the chat. What shape do you think the swimming pool is?
Kind of rectangular, but not really.
Yeah, it's probably rectangular. Okay, so we're going to draw a picture, and my picture is going to look like a rectangle. This is the bird's eye view. If a bird were flying overhead, this is what the bird sees, all right? So this is 20 feet wide, 40 feet long. Now, the bird cannot see the next part. The next part says 3 feet deep at the shallow end and 9 feet deep at its deepest point. The bird can't see that, so I need a different viewpoint of the swimming pool. So what I'm going to do next is what I'd call the mole's eye view, because moles like to dig in the ground. In other words, if you could cut away the ground, and this were the ground right here, so we can put a little tree here, there's the ground, and we're underneath the ground, then at one end it goes down 3 feet, but at the other end it goes down 9 feet. And you can see there's a pretty significant lag. So I've got 9 feet and 3 feet. And it's connected, and we can assume because it's a swimming pool, most pools tend to drop off pretty much gradually. Now, some of them have a more deep drop, but we're going to have to assume it's a straight line like that. So this is sort of the in the ground sideways cross-section view of the pool. That takes care of that whole first sentence. Now we're going to look at the second sentence. If the pool, got it, is being filled, okay, at a rate, okay, of 0.8 cubic feet per minute. So I need to stop and I need to write down 0.8 cubic feet per minute. And then I need to think about what that represents. I know it's got to be a derivative because it said rate. It's got to be with respect to time because it's got minutes in the denominator. It does not say what it's the derivative of, but if I look at the units are feet cubed, and it's got to be volume. The other way to realize that is to ask yourself, well, how do we measure water? If I said, oh, hey, hand me a foot of water, what does that mean? You can't hand me a foot of water. If I say, oh, hand me 5 square feet of water, you can't hand me 5 square feet of water. But if I said, hand me a gallon of water, that you can do. And a gallon is a measure of volume. So water is measured in volume. Again, the units sort of give it away because it's cubic feet. So now I've written down dV dt is 0.8 cubic feet per minute, but is it increasing or is it decreasing? Is the water going into the pool or out of the pool? What word tells us?
It's increasing since it's getting filled.
Yeah, it's that word filled right there. And the other thing that lets you know that is it says the water level is rising. If the water's going up, then I'm getting more volume. So this has to be a positive 0.8 cubic feet per minute. I'm getting more water, more volume. Okay. So now that I've completed the first part of the second sentence, I keep going. How fast, okay, this is what they're looking for, is the water level rising, okay, when the depth at the deepest point is 5 feet. Okay. Depth at the deepest point is 5 feet. Where on the picture is the deepest point? Which end of the pool? As I drew it. Yeah, it's over there on the right end. So Alicia's right. It's on the right side. So if I were to draw a picture of what the water would look like, and I guess I can choose blue, it's got to be like somewhere in here. See how long it takes it to do that. Okay, there's my water. Do you notice that if it's 5 feet deep, it has not left that triangular section at the bottom? Do you see that? If it's 5 feet deep, I'm not out of the triangular section of the bottom. Why not? How do I know I'm not out of that triangular section?
The deepest point is 9 feet, and you would get out of it at 4 because, or no, at 6.
Yeah, exactly. So I'd get out of it at 6. If I drew sort of a dashed line across there, that means that the deepest part right here goes 6 feet below what the shallow end of the pool does. So if the water level's 5 feet, I'm still in that triangular bottom, and I can almost completely ignore the rectangular top. Okay? So I'm still in the bottom of this thing, and it wants to know how fast the water level is rising. If the water level is rising, then what I need to do now is I need to give myself a variable that represents the height of the water level. So what do you want to call the water level? Give me a variable.
H.
H, perfect. I would have chosen H or Y, probably. Or you could call it W for water. That makes sense too. Does everybody see that H is going to be this amount right there? Okay. Now, I'm looking, if I go back to the words, because I'm not totally done yet, I've got the water, I know where in the pool I am, but it wants to know how fast is the water level rising. So that's got to be find the H dt when the depth at the deepest point is 5 feet. That would be when H itself is 5 feet, the depth of the water. So when I'm done, I need to know what that is. I'm anticipating that it would be positive because it is increasing, right? The water's getting deeper, so the height should be getting bigger. So that means it should be positive. So now what I need to do is I need to come up with some kind of relationship between the different values that I was given. I was given dv dt, and I was given that this is 3 feet, the whole thing is 9 feet, and I know the water never gets out of that triangular bottom. I also know that it's 20 feet wide and 40 feet long. So the question is, how can I relate these? Basically, I really need to relate volume to the height of the water. And I'm talking about the water when I'm talking about volume. So what we need to do is compute the volume of that water. So I need a formula that computes the volume of water. So here is sort of a side view of it, like this. Get it all on there. It's kind of hard to draw without seeing the whole thing. All right. If you're looking at it, that shape of the bottom of the pool is like a wedge. All right. Does everybody see that? If you look at the end of it, it looks like a right triangle where this is the right angle right there. But if you look at kind of sideways, it's a wedge. It is a regular solid because if I were to cut it across the pool, they would all be right triangles of the same size and same shape. And it would be from one end to the other. So my question is, what is that measure right there? How long is that side? And again, there's the bird's eye view and there's the mole's eye view. How long is that side?
Sorry, which side are you talking about?
This side right here, how long would that be?
Would that be 20 feet?
Yep, Alicia, you're right. It's 20 feet. So this has to be 20 feet. So remember the formula for volume. The formula for volume is going to be the area of the base, which is the cross section that never changes, which in our case is the triangle. So I need the area of the triangle. I'm going to write in words. And then I need to multiply it by the height of the triangle, but not the height of the triangle, the height of the wedge. Oops, stop. Ugh, lag is terrible. Okay, there we go. All right, so I need to multiply it by this distance right here, which is the distance between the two bases. So that would be times my 20 feet. And this is where I run into a problem, because when I'm looking at the triangle, I know that the height of the water is h, but I don't know that side right there, and that's the side I need. In order to compute the area of that triangle, I need to compute how long that side is right there, and I don't have that side. So what I'm going to have to do is form what's called a similar triangle. And we had to do this on the conical tank as well, if you remember. So here is my big triangle, where this side is 9 feet. I'm going to scoot it over a little so it's more in the center. And I need to know how long is, whoa, keeps moving. Okay, put. And my 9 feet's way too far over to the side. Okay. All right, 9 feet, you've got to come back to the middle. Okay. So this is 9 feet. How long is this side right here? And again, look at the picture. That's that edge on the top.
40.
Yeah, that's 40. That's the big one. After that, we need to look at the water. Whoa, stay. All right. So if I'm looking at the water, then my water is on the inside, which is right there. So if I draw the water triangle below it, like this, I know the height is h, but I don't know that side right there. Can I find that side? That's what I need to find the area of the triangle. Can I use something to find the length of that side? Both triangles use a right angle there in the corner, and both triangles have the same angle at the bottom. And if they have the same angle at the bottom, that tells you that those two triangles have to be similar. You need a ratio. Yep. So I'm looking for the question mark, so I can put that one in the numerator. You can set it up various ways. I would probably do question mark over 40 feet. Since this is the top edge in the little triangle over top edge in the big triangle, then I got to set up the other one in a similar fashion. So I need little triangle first on top. So that will be H. And then I'm going to divide that by the same side on the big triangle, big lag time here, over 9 feet. Once I get that down, I can solve for the unknown, which is going to give me that the unknown side has to be equal to h times 40 feet divided by 9 feet. The feet will cancel, and that tells me the unknown side is 40/9 times h. So if I have 40/9 times h, then the area of that triangle, looking at the bottom of the pool where the water is, the area of the triangle is 1/2 the base, which was that number over there, which was 40/9 h. I've lost track of where I am on the page. Got to wait for it to draw. H. 1/2 the base times the height, which is h. That replaces the area of the triangle. And now I need to multiply it by 20 feet. The 20 feet never changes because that's the measure of this side of the wedge, and that's a fixed constant. So I can plug that in. If I multiply all that out, that gives me 20 squared, since 40 divided by 2 is 20. So I get the volume is 20 squared, which is 400, I think. You guys check my arithmetic. 400 feet times h squared, all divided by 9. So now I have it solved for the one I need to find the rate for. I'm looking for dv dt. I was given dht, and so now I can do implicit differentiation. So I take the derivative of the left and the derivative of the right, and I get dv dt is equal to, the 400 feet over 9 is a constant, so it doesn't change. But the
Actually, I thought we were looking for dH/dt, and we were
you know
given.
what? We're right. What are we looking for? Let me go up and find out again. Oh, you're right. I was given the reverse. We're given dv dt. We're looking for dH dt. Okay, good. And okay, so it won't affect us until we start plugging in, and that's when it'll have an effect. So now I'm going to pull the 2 to the front. So 2 times 400 would give me 800 feet over 9 h. But because the h doesn't match the differential dt, I have to apply chain rule. So the derivative of the inside function is dh dt. And like Alicia said, we're looking for dh dt. So if I'm looking for dh dt, then I need to solve for dh dt. Now you can either solve for it now by moving stuff around, or you can plug in and then solve for it. It doesn't matter, you'll get the same thing. I'm just going to keep going until I get dH dt isolated. So I'm going to have dH dt equals, I need to multiply by the reciprocal of 800 feet over 9 to move it to the other side. So I get 9 over 800 feet. I need to multiply by the reciprocal of h, which is 1 over h. So that's going to put the h in the denominator as well. So I can write that as a separate one. And then I have to multiply that by dv dt. So the point I was looking for was when h was 5 feet, and I was given that dv dt is 0.8 cubic feet per minute. So I scroll down, and I'm looking for dH dt when h equals, what was it, 5 feet? Is that right? Yeah, 5 feet. So I get 9 over 800 feet times 1 over 5 feet times 0.8 cubic feet per minute. You do not want to plug in for h until the very last step, because h is not a constant, it's changing. So at this point, you would probably want to grab a calculator to figure out the rest of it, which got a really old calculator with the, God, this is like a TI-83. This is really old. Okay, so 0.8 divided by 800 divided by 5 times 9. I probably really prefer my sharp right view because this one doesn't always convert to fractions, but I'm getting 9 over 5,000. And then I need to check my units. So I have 2 feet in the denominator and feet cubed on top, so I get feet. And then I have minutes on bottom, which don't cancel, so I get feet per minute. Your last 2 steps are to do a reasonableness check. You're looking for dH/dt. T should be in time units, and it is. H should be in feet units, and it is. And then this does make sense. The volume is increasing at 0.8 cubic feet per minute, which is not a huge amount, but I would need a very small amount of height change to produce a large volume change because the pool is so large. This is a really large pool, a 40-foot long pool and a 20-foot wide pool. This is a massive pool. So it doesn't take a lot of depth to produce a whole lot of water, right? So that's the end of that problem. Let's see, and the next one we had a question about was 115. So let's look at 4.1.15. And, oh yeah, the baseball. Okay. So looking at the baseball problem. So this one I'll probably have to do, copy it in 2 sections to get it to come off. That's it for that. Okay. Okay. So here's our problem, and this is 4.1.15. First, we read it, just get a vague idea of what kind of problem we're dealing with and what it looks like. So I often will draw a pink line or something like that in between problems so you know where one problem starts and stops. Okay. So reading this one, it says the batter hits a ball towards second base at 81 feet per second and runs toward first base at a rate of 28 feet per second. At what rate does the distance between the ball and the batter change when the batter has run 15 feet? Can't recall the law of cosines. Okay, so first we do need to recall the law of cosines, which you probably have forgotten. So the law of cosines is when you take a regular triangle, and it's not necessarily a right triangle. It does apply to right triangles. It becomes the Pythagorean theorem when it's a right triangle. And it says that you know one of the angles. So let's say we know that angle and we call it capital A. The side across from it has to be lowercase a. And then we label the other sides with either B or C. Now this applies for all triangles, not just right. So this says that you can find the square of side A is going to be B squared plus C squared minus 2BC times the cosine, that's a times, of the angle A. So the reason it ends up applying for right triangles is the cosine of 90 degrees is 0, and this whole second term will drop out. But if that's a right triangle, then A is the hypotenuse, and you get that the 2 short legs squared equals the hypotenuse squared. So that's why it is, in fact, the same thing for a right triangle as Pythagorean theorem. So that's the law of cosines. Now we go back and we read it. They did give us a picture And you'll notice that it's got the bases in the corner, but in fact, a baseball diamond is in fact a square, all right? So it's 90 feet on each side, and each of these is at a right angle, right? So that's important that you know that. If you don't know that, it's going to be hard to do the problem, right? Now we go back and we break it up 2 to 3 words at a time. A batter hits a ball towards second base. All right, so I'm going to go to the picture. When you're playing baseball, you're standing at home plate and you hit the ball. So the ball is going this way towards second base. All right, does everybody see that? This is my line that the ball is following. All right. And it's going to go at 81 feet per second. All right, so 81 feet per second. That must be the distance that the ball is traveling. So I'm going to call this side capital B for ball, all right? So I know that the rate of change that the ball is moving with respect to time is going to have something to do with 81 feet per second. I'm not 100% sure yet if it should be a positive or a negative. I'll have to decide where I'm counting from, though I suspect it will be from home base, right? So we'll kind of wait on deciding if it's positive or negative and keep reading. The batter hits the ball towards second base at 81 feet per second, got it, and runs toward first base, okay, at a rate of 28 feet per second. So now I need the runner. So let me pick a better color. I don't like any of these colors. Okay, green. So now my runner is running from home plate towards first, all right? So this is where my runner is. That green's not showing up too well, okay? This is my runner. Make it heavier. I'm going to call that side R for the runner. And I know that the runner is running, how many feet per second did it say? Scroll up. 28 feet per second. Okay. So dr dt has to be 28 feet per second. Now I need to think about the ball and the runner and what they both have in common. The only place the ball and the runner have in common along their path is home plate. So I'm going to measure their distances as being from home plate. Now I need to decide whether these rates that I've written down should be positive or negative. Is the distance of the ball from home plate getting bigger or getting smaller? Is it increasing or decreasing? Getting bigger. If it's getting bigger, then it should be positive. And the same for the runner. So both of those should be positive rates. Okay. Now, let's continue reading in the problem and see what we're actually looking for. Second sentence, at what rate? So since it says at what rate, that means I'm looking for a derivative. Does the distance, okay, between the ball and the batter, and by batter they mean the runner, change? All right, at what rate does the distance between the ball and the batter change? Okay, I need the distance between these two. So I need a color that's going to show up. That right there, which should show up in a minute in red, that's the distance between the ball and the runner. But notice that it's not always going to be a right triangle. So I can't assume it's a right triangle. I don't want to use D for distance, so I'm just going to use L for the length between them. I'm looking for dl dt. That's the rate of change of the distance between the runner and the ball at a point in time. What point in time? When I read the rest of it, it says, when the batter has run 15 feet. The batter is the runner. So that means when R, the distance he's run, is 15 feet. That's the instant in time I want to look at, but I won't plug that in until the very end because R is not staying the same. So now I need to look at this and I need to figure out what the relationship is, but they've pretty much already given me the relationship. They want me to use the law of cosines, and the law of cosines is that relationship there. So now I need to look at this and I've got to find an angle. The law of cosines only has one angle in it. It's got all three sides, but only one angle. The problem with my picture is if the ball were over here, then L is going to be here, which means that these angles aren't 90 degrees. However, there is one angle that I should be able to guess its value. Which one is that? Somebody write it into chat.
The angle B to R.
Yep. If the ball goes directly from home plate in a line drive towards second base, shouldn't this angle right down here, very slow, shouldn't that angle right there be half of 90 degrees? If it's a line drive to second base and it's a 90-degree angle at home plate, then a line drive to second will cut that square in half. So that angle should be 45 degrees. If that's 45 degrees, the side that's across from it is L. That will let me write my formula for the law of cosines with the cosine of 45 back here and L squared at the front. And that's what I want to do. So now I'm going to write the law of cosines with L squared equals B squared plus R squared minus 2BR times the cosine of 45 degrees. The cosine of 45 degrees is the square root of 2 over 2. That means that that 2 will cancel that 2, and I'll just get a square root of 2. Right? So if I rewrite the equation now, I have L squared equals B squared plus R squared minus the square root of 2 BR. I've got a B and an R. I know from looking up above that I'm looking for dL dt and it's solved for L squared, so that looks good. And given dB dt and dr dt, so that looks good. The problem is I don't have B and R. But first I'm going to do the implicit differentiation and get it solved for dL dt. Then I'll worry about how to get the B and the R. So take the derivative of the left and the right side, apply the chain rule, and I get 2L dL dt lag. And I know we're over class time, so if you need to drop off, just drop off. I'm going to record it and I'll post it later. We're into sort of your office hour at this point. But if you want to hang on, just hang in there. So now I get 2B dB dt and plus 2R, oops, I should not have put that there. Okay, took out my R to 2R dr dt. And then what am I going to have to use on the last term in order to find the derivative?
Product rule.
Yep, product rule. So unfortunately, that gives me the derivative of b would be a minus square root of 2 db dt. Leave r alone. I'm kind of running out of room here. I can shrink it a little bit. Minus the square root of 2, leave the b alone, and take the derivative dr dt. Right? Now, looking all the way across, to solve for dl dt, I will need to move the 2l, but I can do that by dividing it on both sides. I get 2l dl dt equals, and I can write it as 1 over 2l times the rest of that mess. All right, instead of rewriting the whole thing, I'll just leave it in parentheses. And I'll put all of this goes here. Okay. All right. So now that I have all that there, I have dB dt, I have dr dt, but I don't have L, I don't have B, and I don't have R. So what am I going to do? How could you get B and R and L? Somebody take a guess. Go back to the problem and look at what you were given. I was given R at the moment in time. What moment in time was I given? R is 15 feet, right? So if R is 15 feet, how can I find B and L? Anybody want to take a guess?
The law of sines.
You could, except you need something more basic than that. I think law of sines might work, but you need something even more basic, which would just be distance equals rate times time. Okay, so the formula that you need to pull out of the hat is D equals RT, right? That's your basic speed times time gives you distance. So my question is, if he's run 15 feet and he's running 28 feet per second, how long did it take him to run the 15 feet? What time is it that the ball and the runner are running? So to do that, I would solve that equation for time, and that would be the distance divided by the rate, which in this case would be 15 feet divided by 28 feet per second. What's going to happen to the feet? Feet are going to cancel, yeah. And the seconds then will swing up to the numerator. So in fact, they're running for 15/28 of 1 second. That's the time it takes them to run. So if I know that, and I know that the ball is moving the same amount of time, can I take that time then and find out how far the ball has gone? What would I need to compute to find that? Go. So then I will take the time, 15 over 28 seconds, and multiply by the ball's rate of 81. And I find that the ball has gone, if it will write, is really lagging. D equals, I need the rate, which is 81 feet per second, times 15 over 28 seconds. The seconds will cancel, and I get 81 times 15 over 28, which I don't think that reduces at all. So it's going to be a pretty nasty fraction, but 81 times 15 divided by 28 as a fraction is 1215 over 28. It does not reduce, right? So it's about 43 feet, but okay. So now I'm going to come down here and put that in. So I know, and that was the ball. So the ball has gone 1215 over 28 feet. And I found that R had gone, what did it say for R? I think R was 15 feet. Yeah. So now the question is, if I have B and I have R, can I get L? And what equation do I use to get L? I'll give you a hint. It's in what you can see right now.
Law of cosine.
Yep. If you come here to the one I'm outlining in pink, that gives you the relationship between B, R, and L. So now that I have B and R, I can find L. So let me do that in a slightly different color so we can contrast them. So I get L is equal to, and this is a pretty nasty problem. I will warn you, the numbers are just horrendous. So be really careful. I have 1215 feet over 28 squared plus, and R squared is 15 feet. So if I squared, I get 225 square feet minus the square root of 2. Okay, my radical is going to have to come down here. Times 1215 divided by 28 feet times 15 feet. This is not a problem you can do without a calculator, not easily anyway. You need to store the 1215 divided by 28 into something so that you can recall it later. And let's see. So now I'm going to square that number. Add 225 to it. And then I'm going to subtract minus, in parentheses, that number. So recall alpha A times the square root of 2 times 15 feet. That gives me the number under the radical, which I got, and I wouldn't even try to get an exact on this one. It's too awful. I've got about 1187.44-ish. And then when you take the square root or raise it to the 1/2 power or the 0.5 power, you get about 34.46. Now you don't want to actually round off. You want to keep all the numbers that are in the calculator. So you need to store that number somewhere else. And I'm going to store it under B. And that gives me L. So now that I have L, I need to come back up here to where I solve for dl dt and plug all those values in. And that will give me dl dt. Does everybody see how to do it? I mean, the numbers are horrendous, but that's basically the process.
Will it be this hard on the quiz?
Josh, no. No,
Okay.
no.
I'm
This
kind
is
of like
like a,
stressed out about that. Like this
yeah,
is
no, this is, I would call this on a scale of 1 to 10, this is a 10. And the ones on the quiz are like 3s and 4s.
okay, cool.
Okay, so level of difficulty, this is more than twice as hard as what's on the test. Okay. This is not reasonable for a quiz or an exam. It's too long. Okay, way too long and too hard. The numbers are too nasty. See, was there another one I needed to do? 17? That was 15, right? Yep, okay. So a little bit more. Okay, so 4.1.17. And let me draw across. Okay. Okay. 17. What's that one? Okay. Okay. So let me make this a little bigger. It's a little small. Okay. So looking at number 17, it says let L be the length of a diagonal of a rectangle whose sides have lengths x and y, and assume that x and y vary with time. If x increases at a constant rate of ½ a foot per second and y decreases at a constant rate of ⅓ of a foot per second, how fast is the size of the diagonal changing when x equal 4 and y equal 2? Okay, what do you guys get out of that reading?
There's a rhombus shape.
Okay,
That's it.
all right. I got rectangle. That's all I got was rectangle, and maybe if I'm lucky, I picked up diagonal. But mostly I just picked up rectangle. Okay. So let me get something uploaded. Okay. All right. So I'm going to draw a rectangle. So I'm going to push this up a little bit so we can still see it. And let's draw a rectangle. Okay. So if I draw my rectangle and I go back to the beginning and I start breaking apart the words, let L, and I don't really like lowercase l because it looks like a 1, so I'm going to use a capital L, be the length, got it, of a diagonal, of a rectangle. Okay, well then I'm going to draw the diagonal. So my diagonal goes from one corner to the opposite corner, and that is L, and I'm going to use capital L. Okay, so if I've got that, then let's see, what else does it say? Whose sides have lengths of x and y. Okay, it doesn't matter which one's x and y, but I'm going to call the horizontal side x and the vertical side y, just to be consistent. Assume that x and y vary with time. Okay, so that means they're either getting bigger or they're getting smaller. So I'm going to draw the rectangle later in time. It says if x increases, well, if x is increasing, then it's getting longer, right? I like that. And it says at a constant rate, okay, of ½ a foot per second, okay. So my x is, oops, maybe I should not draw that one yet. Okay, I'll leave off that one. So that means that dx dt is increasing. So it should be a positive ½ a foot per second, right? And y decreases. Well, if y decreases, then the vertical side gets shorter. So maybe later on my rectangle looks like this, right? So if y is decreasing at a constant rate of ⅓ of a foot per second, since it's decreasing, then dy dt has to be a negative ⅓ of a foot per second because it's getting smaller or shorter. So I've got my initial picture and I've got my later in time picture, and I'm talking about the diagonal of it. So if I put the diagonal on the later in time picture, it's hard to draw that long of a diagonal. But if I get that on there, it looks to me like L is getting longer. Doesn't it look like it to you? Okay, The next question is, how fast, okay, is the size of the diagonal, got it, changing, okay, when x equal 4 feet and y equal 2 feet? Okay, how fast is it? Well, how would you measure the diagonal? Is it a length, an area, a volume? What would it be? Probably be length, right? So I'm thinking that I'm looking for dl dt. So I'm looking for dl dt, and it wants to know when it is x is 4 and y equals 2. So long vertical bar, and then I could write down next to it x equals 4 feet, and underneath I can put y equals 2 feet, right? And when I'm done, I should have that filled in. So looking at my picture, I need to relate x, y, and L. Now this is a reasonable question for the quiz, all right? This is a reasonable one. So how would what's the relationship between x, L, and y? I mean, what formula would you use? It's not on there, but you got to come up with it.
Pythagorean, because it's an angle.
Yeah, it's a right angle. It's a rectangle, so you can assume that all the corners are right angles. And so you should have right angles in all of these corners, so you can use Pythagorean theorem. So writing the Pythagorean theorem, let me get a better color to write with. Let's do brown. We haven't done brown in a while. Okay, so that's going to give me x squared plus y squared equals L squared. And I'm trying to find dl dt, so I'm going to do implicit differentiation. So the derivative on the left and the derivative on the right with respect to time. So that's going to invoke the chain rule. So I get 2x dx dt. That looks like a t instead of an x, plus 2y. Oh, I should not have put that on there. Okay, dy dt equals L dl dt. And again, that's chain rule because these variables do not match the differential. You have to take the derivative of the outside function, which is the second power, and multiply it by the derivative of the inside function, which is x, y, and L. All three of these terms have a 2 in them. So the first thing I'm going to do is get rid of the 2 by dividing everything by 2. And then I don't have to deal with the 2's anymore. So my next step is going to be to solve for dl dt by multiplying by the reciprocal of L. So I have dl dt equals 1 over L times, what would be left? X dx dt plus y dy dt. I think that's it. Okay. Now I was told to find this when x is 4 and y is 2. And I was also given, originally, I was given the values for dx and dy. So dx dt is a half of a foot per second and dy dt is a negative 1/3. So help me remember those. So x is 4 feet. And dx dt, it will catch up with me finally, come on, times 1 foot every 2 seconds, or half a foot per second, plus, and y is 2 feet, but its rate of change was a -1 foot every 3 seconds, or a third of a foot per second. What's the one piece I don't have yet?
L.
I don't have L. How do I get L?
Pythagorean Theorem.
Yeah, back up here to this equation right here underlined in orange. So I'm just going to come down below it. And I know that X is 4 and Y is 2. So L has to be the square root of 4 squared plus 2 squared, which is the square root of 16 plus 4, which is the square root of 20, which is the square root of 4 times the square root of 5. So that gives me 2 square roots of 5, right? Multiplying out the units and combining, I should end up with, and this is feet. Don't forget that that is feet because it's L. So I get 4 feet times a half, which would give me 2. So I've got 1/2 square root of 5 feet times 2 square feet per second minus, because of the negative here, 2/3 of a square foot per second. And then 2 minus 2/3 would be 6/3 minus 2/3, or 4/3. So I get 1/2 square root of 5 feet times, what did I say? 4/3? No. 6 minus 2, yeah, 4/3. So 4 square feet every 3 seconds. And now the question is, what happens to my units? I've got a 4/2, so that will reduce to a 2. And I've got the 3 and the square root of 5 in the denominator. So 3 square roots of 5. I've got square feet over feet, so that gives me feet. Hurry up and finish writing. And then I've got seconds in the denominator. And then I do my reasonableness check, and I have 2 ways to check. The first one is I check the units. So when I check the units, is dl dt going to be measured in feet per second? Yes, probably. I got a positive value. Does that match my picture? Did L get longer? Yeah, it did. So it looks good. And that's more reasonable for the test. Something like that, or the ladder problem, or the cylinder problem, or the conical water tank problem, something like that. That's what you should expect on the quiz. Any other questions that you have to ask? Nope. Okay. Well, I'm going to let you guys go so you can log off, and I'm going to stop recording, and then I will upload this into that online module for this week. And then we'll meet here again tomorrow at noon, and we'll do the same thing again. So if you're working on homework tonight and you run into problems on the homework, be sure you ask me questions about it. The homework quiz will open at 2:05, right? So exactly an hour after class gets out. So yeah, it will open at 2:05 tomorrow and be due before midnight. Okay? All right. You guys have a great day. Try to get outside some and, stay away from people, right? 6 feet. Okay. If you have to leave for work at 2, Zach, will you be home in time to do it, or would you rather do it before class? Because you can do it either way. Just send me an email when you have time to do it. You probably want to allow maybe 30 minutes to do the quiz. Okay. So send me an email, Zach, and I'll open it up for you at that time. Okay. All right. Talk to you guys later.